Thank you all guys for having me here today. My name is Michael. I'm the CEO and co-founder of Lacoon Mobile Security. And today we're going to basically discuss and demonstrate some of the mobile attacks that are going now on the BYOD or corporate devices, mobile devices. And clearly we will also discuss about how to prevent them. So 3 seconds vendor pitch before we jump into the threat landscape and the demos. We are currently the leading provider for the most comprehensive solution for threat detection and mitigation for cyber threats on iOS and Android. As you can see, we work with some of the big names, like both in the financial, tech, legal, insurance, and so on and so forth. And we definitely integrate with some of the vendors that you guys might be using for managing mobile devices, like AirWatch and Mobile Iron, and Good Technology, SIM systems, and so on and so forth. So here the question is, why do you need to protect the mobile devices? And as was discussed when Mike was presenting, now we have consumerization of IT. So basically, the employees are using the mobile devices as their primary computing asset. They're accessing all the business applications. And if a while ago, the business applications were basically interacting within the closed environment behind the perimeter. Now either we're exposing the internal perimeter outside for the mobile devices to access those business applications, or those business applications are moving to the cloud and being accessed by the mobile devices. Now, if we look on the other side, what the hackers are doing, clearly for them it's quite compelling for 2 reasons. One, if they are able to infect a mobile device, they can be extremely evasive. Those are, as we said, those are consumer devices, so there are not many protection or detection mechanisms over there. Clearly not what we are used to from a defense in-depth perspective. And also they can access the information that we are trying to protect. So the way that they actually go around and infect mobile devices is by evolving the traditional methods that they were infecting the internal perimeter. They evolved the traditional malware to mobile malware, the traditional remote access Trojans, the targeted attacks, to mobile remote access Trojans that we will demonstrate shortly. We have network attacks, so when you're connected to Wi-Fi in a Starbucks, they can create a man-in-the-middle attack. And clearly, they leverage exploits to either propagate the malware to the device, or if they already have an app on the device, to break the built-in security of the mobile operating system. And once they were able to do that, they can pretty much do everything. So grab the emails, information within secure containers, information within apps that either you develop or your employees are using, credentials that are being stored or typed on the device. And not only the traditional type of information, but also there is a lot of sort of private and business information on the device as well, like text messages, calendars, phone calls. And they can also activate the sensors remotely. So imagine a board meeting or a trading floor or an employee which is meeting with a client. They can tap into that meeting and record the whole meeting. So, bless you. So let's actually show you, a lot of people are aware that those threats exist, but it's always good to show a real example how cyber criminals are doing those things. So let's talk a little bit about the life cycle, and we'll start with the Android operating system, and then we will jump into the iOS, which is a little bit even more intriguing. The first thing that I would like to show you is a tool which is called Dendroid. It's actually a tool that the cyber criminals are using to inject what we call a remote access Trojan into Android apps, and then sort of redistribute those apps and infect mobile devices. So this is actually a demo that we've recorded, and right now they will actually infect a Marriott app, which is the app that probably some of you or some of your employees will use when they will check into a Marriott hotel. So what they do, they just go into the official Google Play Store. That's the Android App Store. They download it from there, and what you see now in the background is what we call the Dendroid Injector. So that's essentially the tool that the hackers have published that allow you to take any application, allow them to take any application on Google Play and inject a Trojan into that application. And basically, you have two buttons. You just select the app and go, and that basically sort of decompiles, injects, recompiles, and signs the app. So what you see is that it's actually doing this process in the background, job complete, and right now the only thing that they need to do is to change it from, change the file name to something which is more compelling, like Marriott.apk. Now, clearly now they have this infected Trojan. What they need to do now is to somehow get this Trojan on the device. And there are multiple ways that they can do it. Actually, the number of infection vectors on mobile devices is greater than what you would think about the traditional ecosystem. So clearly, phishing is a good way, emailing. But you can also use text messages, SMS, spear phishing using the same methods. Physical access is something which is quite popular on more of the targeted attacks. You can also upload the malware into the App Store, Wi-Fi, and even the QR code that people would scan. And again, an example of how exactly it is being done. What you see on the right-hand side is a website that allows people, or the bad guys or the good guys, to send text messages anonymously. And now they're basically sending a text message. On the left-hand side, that's actually the screen of a Galaxy S5 device, which is one of the newest devices from Samsung, running one of the latest Android operating system. And what you can see now that it actually received the text message. It takes a few seconds for it to open up. And eventually it's just regular social engineering, right? So the text message says, hey, download our app and we will upgrade your room in the hotel or whatever they want. And I can guarantee you that most of the people will actually download the app, install it. They will click through the permissions because most of the apps that just require too many permissions and people don't really care about that. And once they install it on their mobile device, it will look to the hackers like a regular app, right, to the user. But the hackers right now own the device. Basically, there is a Trojan which is running in the background and owns the device. So, second. Right. So the next thing that they need to do, once they own the device, they can do a bunch of things. One of them is actually to start and steal the different account information. As you probably know, if people have email configured on their phone, that email is being stored as account information. Over here, it's the Gmail. But also, the corporate account is also stored on the device. For example, here we use a secure container called Divide. It's a secure container which is provided by, it's an MDM which is provided by Google. It's a company they acquired. And it's an Outlook email. And what you would see in a second is actually the dashboard of the hackers. This is how it looks like. This is their front end, how they control all the devices that are infected. And now they selected the device which was infected previously on the previous screen. They can first of all figure out the location, right? They trigger the GPS. They know where's the location. You can see that the device is located in Washington, D.C. Usually, there are quite enough interesting people or assets in Washington, D.C. So that actually makes the device pretty interesting. And now they will put the accounts that are on the device. So as you can see, they type 10 over there, get 10 accounts from the device. And here we go. They received the list of the different accounts that exist on the device. As you can see, the Gmail account, but also the Outlook account. So now they know that this is actually a pretty valuable device that might contain quite a lot of valuable information. And here we actually installed a bunch of MDMs which are supposed to protect the information on the device. Now, how do they actually know that there are valuable applications on the device? They can pull the list of applications from the device. So now they pull all the applications on the device, and now they can understand what information they should actually target. And it's a pretty long list of all the apps that are installed. And now we will show you that if you search, you can see that there is an AirWatch over here, mobile iron. What else do we have? Good technology, and clearly Divide, which is the one that I've showed you earlier, that has the account configured. So, how many of you have heard about that MDMs or secure containers supposed to protect the data? Great. How many of you think that it's sort of a bulletproof solution for doing that? Okay, only David thinks so. But so the reality is that that's not exactly the case. Basically, the same way that hackers have used exploits for desktops, they actually evolved the same concept into the mobile. And we have something which we call an exploit kit for mobile that basically allows apps to gain elevated privileges or root on the device. Basically, almost every Android version is vulnerable to that. And once an app was able to gain elevated privileges, it can do any of those things: keylogging, memory scraping, hooking, and screen scraping on the device. And I'll show you an example of how exactly that's being done. So we'll show you screen scraping. It's the most visual way to understand how the hackers get the info. So that's a secure container, right? It's pretty equivalent to every other secure container that you've seen used, using, pitched. And there is an extremely confidential email over here, which is basically provides information about the latest results of a public company being sent from one trader to another trader. And this line of code that you see over here, this is essentially a remote command that the hackers can execute at any point in time and grab the screen of the device. Now, this is only one of the methods. Actually, if you want to do it in a larger scale, you will just install a keylogger, but clearly it will not be as visual as we would see in a second. And once that was done, you can basically grab everything which is being typed or extracted from the device. So the command is being executed, and then they will just get the photo from the device, and here you go. Basically, all the information, all the data that you had in that secure container concept or in that encrypted partition is now available for the hackers. So this is essentially what we've discussed. Everything that we discussed so far was about Android. But clearly iOS, a lot of organizations are using iOS because iOS is more secure. How many of you think that iOS is more secure? You're right, iOS is more secure. But again, iOS is not bulletproof, and actually in the last couple of months we've seen an increased interest by cyber criminals to attack and infect iOS devices, mainly because they are used by more valuable targets. And this is sort of a list, what you see on the left-hand side. This is a timeline of the recent attacks. So the iOS successor, that actually was discovered by Lacoon, by our company, was the first Chinese attributed nation-state attack on iOS devices. We discovered that in Hong Kong. Then there was a Wirelooker, again a Chinese spyware, mask attack vulnerability, which was disclosed by FireEye. And the latest and greatest was the Pawn Storm, which you see on the right-hand side. This is a Russian cybercrime attack that was done on mostly government, defense, energy, and media companies. Was going on through February, up until recently, I guess. And the way that they're actually propagating the malware to the device, it's quite an interesting way. It works on non-jailbroken iOS devices, and it actually leverages a big loophole that Apple has in their ecosystem. Basically what we call enterprise provisioning. So essentially you can obtain a certificate that allows you to sign any app and distribute it to other people. And I would actually like to show you that live because it is quite impressive. So let me show you this on this device. Hopefully it will work. Okay, great. So this is an iPhone with the latest operating system. And what you see over here is actually an invitation, a link that was sent to me for RSA conference. And looks like the real page from RSA conference 2014. And clearly, I would like to download the app. It will ask me if I would like to download the app. I will press install. Just a second. Hopefully, if I have a reasonable internet connection. Okay. Like all the demos that you try to do live, they always don't work as you would expect. Just a second. Okay, let's try it again. Okay, let's wait. Here we go. That's just to protect people not to infect themselves. Okay. So, as you can see now, there is an app which is loading in the background. And it was not downloaded from the App Store. Basically, the way this is the loophole of the enterprise certificate, which allows to sideload applications to any device. And clearly, if the certificate was stolen by some entity in China or some entity in Russia or whatever it is, you can actually target with that certificate any iOS device in the world, as long as the user will do 2-3 clicks, as we'll see in a second, once that will load. So let's give it a few seconds.
Can I ask you a question while that's
Sure. Yeah, it'll be a good use of the time. That's good.
You were talking earlier about being able to put a Trojan into a mobile app by reverse engineering code.
Yeah.
Any comments on the ability of some commercial or open source software that attempts to do immense obfuscation on code so that reverse engineering techniques are not possible? Do you have any thoughts on that?
Yeah, we've tried. We actually evaluated a couple of them for various reasons, and I must say that some of them are doing better job than others, but none of them is actually reasonably bulletproof against that type of attack. Yeah, actually, like the point is that you can almost inject, like if you want to inject the Trojan, you don't really care about the obfuscation. You just do it one step before the obfuscated code is being called. Okay, so it's pretty useful against human reverse engineering. If someone really tries to understand how your app works, but not against the injection type of attack. Okay, so.
Have you seen like Pakistan kind of protection?
Yeah, we've seen that. Yeah.
What do you think?
I mean, I think, again, it's pretty much the same as I've said before. I mean, it does protect you from someone reverse engineering the app and figuring out what's going on over there. But if you try to, you can still sort of hide, inject something over there. That's what we've seen previously. I'm not sure exactly.
So injection without actually understanding what the application is.
Yeah, exactly. Yeah.
So, I think it's very cool, and don't mean to be critical, but in reality, this is the same thing we've seen for many years, just in a different format. Once you, on social engineering, once you get people to click on a particular thing in the browser, or, click on a consent in a video, people infect people through YouTube videos, through flash video exploits. I mean, this is basically the same thing. At that point, the game is lost. And whatever software you install, whether it's your company's software or secure container, you can think of it basically like an antivirus. So it's kind of the same thing all over again. Just like, you get a person to click on a particular thing, install whether it's a computer or device, and then you have a software to protect. So like, how is what you demo different from just, downloading regular software on a computer? I mean, here you send it by text messages.
No, I'm just saying, actually, I don't say it's different. It's actually the same thing, just on mobile. The only thing which is different is that it's like, pretty small screen compared to that, but the results are pretty similar.
Have you seen, just curious, are you seeing any of this distribution happen through fake Wi-Fi hotspots, like people setting up fake?
Yeah, we've seen in one of our customers, we've detected a man-in-the-middle attack that was done in their environment, which was, I don't know if they were trying to propagate, but definitely that was part of that. And we heard, or there are companies who claim that they've seen a drive-by which were triggered by those Wi-Fis. But I mean, that just saves that click that the user needs to do, right? It's not much different. So as you can see, we have this RSA app, right, on the device, and except of the disclaimer over there, it looks like the real app for people. And I'll hand you the phone, okay? So this is the dashboard of the hackers, that's how they control it, right? The first thing that they can do is essentially they can collect metadata from the device. So that pulls some of the information which is accessible for the apps on the iPhone, like calendar records, context list, and etc. And it's being delivered to this command control. Right. So you can see here that you can actually receive quite a lot of data, like the context list and GPS location. Right now we are indoors, so you don't see that. Some information about the version of the device and so on and so forth. Calendar records, and again, email, some email information, device ID. All that information is quite valuable. Now think about if you have someone's calendar records, right? And you are able to trigger the recording on the device. So right now, you can. Hey. Right now, it's basically recording everything which is in the room. Do you see something on the device? Yeah.
One thing is I can see that every now and then sending information because.
Right. But you can, if you just close the screen and you put it in your pocket, you probably will not see anything. And this stuff is also going to be sent here.
Is this the actual RSA app, or this is actually a fake version of the RSA?
That's a fake version. That's an infected version of the app.
No, but this is you just created a screen with RSA, right? That's actually the actual RSA conference.
That's the actual RSA conference.
You injected.
Yeah. Yeah. Up. Yeah. Right. So that takes. Here we go. So we have the recording now. Yeah.
That's scary.
Right now, it's basically recording everything which is in the room. Yeah. So that's just a recording. We also have it on WebEx. The what?
Where do you get the console?
The console was something that we've just hooked into that.
The trade secret.
Yeah, it's trade secret. So that's pretty much it. Questions?
Yeah, can you describe in more detail the certificate exploit that was required to install
That thing?
infected RSA, the tampered RSA?
Sure. So the point is that there is a concept called enterprise apps in Apple. Basically, every company can develop their own apps and distribute it to their employees without going through the App Store. The process requires you to submit a request to Apple, pay, I think, about $300, submit the DNB records, and then you get the certificate. Now, what actually happens is that apparently either they somehow fraudulently managed to get those certificates, right, by sending, I don't know, fake requests to Apple or something like that, or what is probably the real use case is that they would hack some company, get the certificate from them, get their certificate, and then they can distribute to everyone else.
So the flaw in the Apple flaw is that any enterprise certificate, he buys an enterprise certificate, I buy one, he buys one, but any phone that receives a app signed with that, any one of our certificates,
right,
will
correct.
accept it. Basically, every phone will accept
you will have a
signed with an Apple certificate.
correct. You know, the only thing I'm not sure if you saw it, but you know, when I open the app, it asks me if I trust the developer. Okay, so you have one button which separates you. Correct. Yeah. Yeah.
So in other words, if this certificate belongs to Brunswick of DNB maintainer using those apps, in theory, I mean, there's solutions for this.
No, I think
Yeah. Last question there in the back, and then we'll wrap up the next session.
Very nice presentation. So Android, I can understand, it's open source, you can inject. Back to the idea of certificates. I work in enterprise apps for a lot of financial services, and you do enterprise builds. Part of the build is that you cannot deploy or download any provisioning. So if you're a company, if I'm a decision maker for a big company, I would say don't use Android, always use iOS, and give us the phone once you want to work with us, and we can have it lock down downloading any apps from the overhead. And if you do that,
That's not practical because you have to, first of all, it has to be supervised device.
yes,
No, supervised device is like a device which is completely blocked, you know, from downloading everything. It's like what you have in kiosks. No, you don't have it on Apple. You have it on Android.
You can do it with enterprise build. But you have to get the device. You have to have access to the device.
Yeah. Okay.
So if you want to be very secure about it.
Okay, Michael is going to be available for
Yeah,
a question.
I'll,
He's going to
you
be
know,
here. Let's take 5 minutes, and we'll go off to the next session.
what do you do to stop this?
I need to buy a product. So yeah, I didn't have time to get to how the product. So we have actually let's just go quickly. We basically have the Lacoon Threat Management Platform. It's essentially a service that you run on top of your MDM or independent of your MDM. It has a behavior risk engine that detects the compromised apps or compromised operating system and compromised networks. And then we also have, on top of that, it automates incident response process that notifies the user if it's compromised. It integrates with the leading MDMs that I've mentioned to push the device outside of the network. And also, it provides network protection in case the device is compromised and the user is sort of lost and needs immediate protection. Okay, that's
perfect. Thank you. So 5 minutes, and then we'll go to the next session. Thank you.